students, myself, Hanasha, Assistant Professor at LG Institutes of Engineering and Technology. Today we are going to study few more topics of applications of partial derivatives. So let us begin with the first topic, that is we have to find extreme values with constrained variables. Sometimes we have to find extreme values of a function of 3 or more variables, say f of x, y, z, which are not independent but are connected by some given relation g of x, y, z is equal to 0. The extreme values of f of x, y, z in such a situation are called constrained extreme values, right? In such situations, we use g of x, y, z is equal to 0 to eliminate one of the variables, say z, from the given function, thus converting the function as a function of only two variables and then find the extreme values of the function. So now let us study the method to find extreme values with constrained variables. The method is known as Lagrange method. So let us go to the steps of Lagrange method. Let u is equal to f of x, y, z be a given function subject to the constraint g of x, y, z is equal to c, where c is a constant, right? So this will be given in your question. Now the extreme values can be obtained by using following steps. So step 1. Firstly, we have to form Lagrange equation, which is given by f is equal to, this is capital F. Capital F is equal to f of x, y, z plus lambda times g of x, y, z minus c, where lambda is known as Lagrange's multiplier, right? So in short, we can represent this as capital F is equal to small f plus lambda g. So this will be our first step. Now let us go to the step 2. Then we have to find the partial derivatives with respect to x, y, z and equate it to 0, right? That is del f by del x is equal to 0, del f by del y is equal to 0 and del f by del z is equal to 0. Now next step. Find the values of lambda from each equation. That is, we have to find the values of lambda from all the three equations, right? Next, step 4. Find the values of x, y, z and also find the corresponding value of f of x, y, z. That is, we have to find the values of x, y, z using our step 3 and g, and then find the value of f of x, y, z. Now, let us solve an example using this method. So, the example is, the temperature T is given by T is equal to 400 x, y, z square. We have to find the highest temperature on the surface of the unit sphere x square plus y square plus z square is equal to 1. So this is your f and this is your constraint, that is g. So let us begin the solution. So firstly, t is equal to 400 x, y, z square and g is equal to x square plus y square plus z square minus 1. This one we are taking on this side. Now from Lagrange equation, f is equal to t of x, y, z plus lambda times g of x, y, z minus c. So we will put these two equations now. So therefore, f will be equal to 400 x, y, z square plus lambda times x square plus y square plus z square minus 1. Now we have to find the partial derivatives of f with respect to x, then y and z. So our f is what? 400 x, y, z square plus lambda times x square plus y square plus z square minus 1. Right? So we'll start finding the derivative of f with respect to x and equate it to 0. Keeping what constant? We have to keep y and z as constant. So let us find the derivative. So derivative of x will be 1. So answer will be 400 y z square plus lambda times derivative of these three terms will be equal to 0 because they are constant. So derivative of x square will be equal to 2x and we have to equate it to 0. Now make lambda as a subject. Therefore lambda is equal to minus 200 y z square upon x. Now name this as equation 1. Now let us find the derivative of f with respect to y and equate it to 0. Firstly we have to keep x and z as constant. So let us find the derivative. So 400x square will remain as constant and derivative of y will be equal to 1 plus lambda times this 1, 2 and 3 terms are constant, so derivative will be 0 and just the derivative of y square will be equal to 2y. Now equate it to 0 and make lambda as a subject. So lambda will be equal to minus 200x square upon y. Name this equation as equation 2. Right? Now let us find the partial derivative of f with respect to z and equate it to 0. So we have to keep here x and y as constant. Done? So keeping x and y as constant, find the derivative of z square. It will be equal to 2z. So finally the answer will be 800xyz plus lambda times. Now find the derivative of this keeping x and y constant. So this is constant, and this is constant. So derivative will be equal to 0 and derivative of z square will be equal to 2z. Now equate it to 0 and make lambda as a subject. Therefore lambda will be equal to minus 400xy. Name this as equation 3. Now what we have to do? We have to find the values of x, y and z from 1, 2 and 3. So firstly we will equate equation 1 and 2. So equating equation 1 and 2 we will get minus 200yz square upon x is equal to minus 200xz square upon y. Now minus 200 will get cancelled out, z square will get cancelled out from both the sides. So finally we will get x square is equal to y square. Now let us equate equation 2 and equation 3. So on equating we will get minus 200xz square upon y is equal to minus 400xy. So this minus will get cancelled out, right? Next 200 will get cancelled out and here will come 2. Next x will get cancelled out. So finally what will remain? Z square is equal to 2y square. Now we are given x square plus y square plus z square is equal to 1. Now we will replace x square by y square and z square by 2y square. So what we will get? 4y square is equal to 1. Therefore y square is equal to 1 upon 4. Therefore y is equal to plus or minus 1 upon 2. And also x square is equal to y square. Therefore again x also will be equal to plus or minus 2 and z will be equal to plus or minus 1 upon root 2. Therefore we will get two types of points, that is x, y, z is equal to 1 upon 2, 1 upon 2 and 1 upon root 2. And x, y, z will be equal to minus 1 upon 2, minus 1 upon 2, minus 1 upon root 2. Now we will put both the points in our t. So finally t max will be equal to 50 units because t is equal to 400xyz square. So if you put this point or this point, you will get answer as 50 units only, right? So this is our highest temperature T on the surface of the sphere. Now let us go to our next example. That is a rectangular box open at the top is having volume 32 cubic units. We have to find the dimensions of the box requiring least materials. That is, we have to find length, breadth and height of the rectangular box. Now let us go to the solution. we will suppose the dimensions of the box as x, y and z. And now we are given volume V is equal to 32 cubic units. Now volume of a rectangular box is given by x, y, z. Therefore x, y, z is equal to 32 units. Right? Now surface area of open rectangular box will be given by S is equal to xy plus 2yz plus 2zx. Because this is an open box, therefore here it will come only xy. Now let us begin our method, that is we will write our Lagrange equation, which is given by capital F is equal to S of xyz plus lambda times V of xyz minus c. Here the constraint is xyz is equal to 32. So let us put all the values. Therefore, f is equal to xy plus 2yz plus 2zx plus lambda times xyz minus 32. Now let us differentiate this with respect to x first, keeping which terms constant, y and z as constant. So what we will get, y plus 2z plus lambda times yz is equal to 0. Now make lambda as a subject. Therefore lambda will be equal to minus y plus 2z upon yz. Name this as equation 1. Now we will find del f by del y and equate it to 0. In order to find this, we will keep x and z as constant. So keeping this constant, what we will get, x plus 2z plus lambda times xz is equal to 0. Therefore lambda is equal to minus x plus 2z upon xz. Name this as equation 2. Lastly, find del f by del z and equate it to 0. So here you have to keep what constant, x and y as constant. So keeping these two constant, you will get 2y plus 2x plus lambda times xy is equal to 0. So therefore your lambda will be equal to minus 2y plus 2x upon xy, and name this as equation 3. Now we will equate equation 1 and 2. So on equating you will get minus y plus 2z upon yz is equal to minus x plus 2z upon xz. Now this z gets cancelled out. Again simplify. So you will get xy plus 2zx is equal to xy plus 2zy. Now what will get cancelled out? Xy will get cancelled out. So finally what you will get, x is equal to y. Now equate equation 2 and 3. So on equating you will get minus x plus 2z upon xz is equal to minus 2y plus 2x upon xy. Here x gets cancelled out. Now you simplify. That is, take this on this side and this on this side. Therefore you will get xy plus 2zy is equal to 2zy plus 2zx. Now this will get cancelled out. So finally you will get y is equal to 2z. Therefore x is equal to y is equal to 2z. Now put this in your constraint, that is x, y, z is equal to 32. Therefore you will get 2z into 2z into z is equal to 32. Therefore simplifying you will get 4z cube is equal to 32. Therefore z cube is equal to 8. Therefore finally the value of z will be equal to 2. Therefore the values of x will be 4 and y will be equal to 4. Therefore x, y, z will be equal to 4, 4, 2. Therefore the dimensions of the box requiring least material are 4, 4 and 2. Right? Next, let us go to our next example. That is, we have to find the shortest and longest distance from the point 1 to minus 1 to the sphere x square plus y square plus z square is equal to 24. So you are given your constraint as this, but we don't have our function f. So let us begin the solution by finding the function f. Firstly, we will suppose x, y, z is a point having shortest and longest distance from 1 to minus 1. Therefore, we will use our distance formula. Therefore, f will be equal to d square is equal to x minus 1 whole square plus y minus 2 whole square plus z plus 1 whole square. You all know your distance formula, which is given by d square is equal to x minus x1 whole square plus y minus y1 whole square plus z minus z1 whole square. What we have done? We have replaced x1, y1 and z1 by 1, 2, minus 1 in order to get this, right? Now our g is x square plus y square plus z square minus 24. So now we will form our Lagrange equation, which is given by capital F is equal to small f plus lambda times g minus c. So put all the values. Therefore, f will be equal to x minus 1 whole square plus y minus 2 whole square plus z plus 1 whole square plus lambda times x square plus y square plus z square minus 24. Now let us find the derivatives and equate it to 0. So firstly we will find del f by del x and equate it to 0, right? Let me write the function, that is f is equal to x minus 1 whole square plus y minus 2 whole square plus z plus 1 whole square plus lambda times x square plus y square plus z square minus 24. So now let us find the derivatives with respect to x, keeping y and z as constant, right? So the derivative will be 2 times x minus 1 plus lambda times 2x is equal to 0. Therefore, lambda will be equal to 1 minus x upon x. Name this as equation 1. Now find del f by del y and equate it to 0. So here we have to keep what constant? X and z as constant. So the derivative will be 2 times y minus 2 plus lambda times 2y is equal to 0. Therefore, lambda is equal to 2 minus y upon y. Name this as equation 2. Lastly, find del f by del z by keeping x and y as constant and equate it to 0. So what you will get? 2 times z plus 1 plus lambda times 2z is equal to 0. Therefore, your lambda will be equal to minus 1 plus z upon z. Name this as equation 3. Now what we will do? We will equate equation 1 and 2. So on equating, you will get 1 minus x upon x is equal to 2 minus y upon y. Now simplify. Therefore, you will get y minus xy is equal to 2x minus xy. Here xy will get cancelled out. Therefore, you will get x is equal to y by 2. Now let us equate equation 2 and 3. Therefore, 2 minus y upon y is equal to minus 1 plus z upon z. Now simplifying, you will get 2z minus yz is equal to minus y minus yz. Now this yz will get cancelled out. Therefore, you will get z is equal to minus y by 2. Now using these conditions, we will simplify x square plus y square plus z square is equal to 24. So put x is equal to y by 2 and z is equal to minus y by 2. You will get the following. Now simplify. So you will get 6y square upon 4 is equal to 24. So y square will be finally equal to 60. So y will be plus or minus 4. Therefore, your x will be what? Plus or minus 2 and z will be minus plus 2 because x is equal to y by 2 and z is equal to minus y by 2. Therefore, your points are 2, 4, minus 2 and minus 2, minus 4, 2. Now we know that d is equal to x minus 1 whole square plus y minus 2 whole square plus z plus 1 whole square. Now we will put these 2 points. Therefore, firstly we will put this point, that is d at minus 2 minus 4 2. So we will get this, and on simplifying you will get answer as square root 54, which can be simplified as 3 root 6. Now we will put this point in our d. Therefore, d at 2, 4 minus 2 will be equal to square root of 2 minus 1 whole square plus 4 minus 2 whole square plus minus 2 plus 1 whole square. On simplifying, you will get answer as root 6. Now you can see that this is our maximum distance and this is our minimum distance, right? So in today's lecture, we have studied Lagrange method. I hope you have understood the method. Thank you for watching.